Okay, so I'll start with the, going in order of the design pattern, starting with the Singleton. So for my sprite box manager, it has a instance variable, which is of type sprite box manager, and it inherits from the base manager. And if we go here, we can see that this is a static instance variable. And this, in combination with the create and privget instance method, which is used to access my instance in all the static methods, these three things allow for a single instance to be to ensure that only a single instance can exist of this class. And so if when the user calls create, if it hasn't been created already, so if the instance is null, we create it. And then for my particular implementation, if I don't force my users to call create, if they call a method and create hasn't been called yet, meaning that the instance is null, then I'll just call it for them. And that's how the Singleton works for mine. And so now moving on to the factory. For the factory, the way I'm creating my my grid as a whole and the aliens is my alien factory is a Singleton, and this is just in foresight of needing like for the possibility of having multiple games in one session. So I figured this makes sense for it to be a Singleton for now, but that's just temporary. So moving on, my sprite, I get the sprite batch, I store that, and then in my factory, I also will initialize all of the images, the textures, and the sprites, and then also the animations for each of the three aliens. And then right here is the actual method, which I call right in my load content. So to create a alien grid, I just attach, I create the grid and attach columns to it by adding them right here. So given the grid, it adds it to the composite grid object. And then right here, once again, given the column, it adds a created game object to the composite column object. And so this is how my factory is working, basically. So moving on to my object pooling with the image manager. The thing to note here is that the image manager, in its remove and its add functions, it is simply just delegating all work to the actual base manager. So moving to my base manager, we could see that when we remove a node, we remove it from the active list, add it to the reserve list. And when we add a node, once again, we remove from the reserve list and add to the active list. So that's me making use of this memory pooling active and reserve list. Okay. So moving on to the timer event manager, the priority queue. And this is pretty simple. I use a iterator to iterate through my list. And since I am inserting in sorted order, which you can see right here, I just delegate that responsibility to the base manager, which delegates to the base collection. And so since I'm inserting in sorted order, once I run into a node on my list that is not less than the current time, less than or equal to the current time, at that point I can't process it, so I just break out of this loop and I stop iterating through my list, and that's it. So that's how I early out from processing timer events. Okay. And now for the proxy, I'm going to go ahead and, I guess I can show this briefly, but essentially the way it works is a game object holds a sprite proxy, and it will update the sprite proxy's state, X and Y variable, and the sprite proxy, when it's rendered, it will update its sprite, and I'll just show that in the code. So the game object updates its proxy's position, and so the sprite proxy has state, and which is X and Y, and then a sprite that it points to. And so when we update the position, we update the X and Y, and then when render is called on each sprite proxy, it will push its data, its current state data, to the sprite, and then it will update it, sending that information to the Azul sprite, and then it will render it, which will draw it to the screen for this current proxy, and then rinse and repeat for each instance of the proxies. Okay, so for the command pattern, the way I'm doing this for my grid movement is that I simply, in my game, I create a timer event manager in the load content, giving it a delta time of 0.5, and so every 0.5 seconds I will execute this command because I'm adding it back to, after execution, I add it back to the time event manager. So that's the repeating nature of this. And essentially the move just works by, this is a composite object. When it calls move on the grid, which it finds right here. So this is really a grid move command. But when it calls move on the grid, it will relay that message to each of its components that it holds in its list, in its composite list. Okay, so now moving on to the iterator. The way the iterator works, my UML doesn't really show it that well because I'm using the nested class design. I still like that layout. But the way it works is my base manager has a active and reserve list, which are of type base collection, and a base collection has a method called get iterator. So it forces the derived collection, such as a D-link collection, to implement this function and have an iterator. So I have a D-link iterator, and all the iterator really does is it just holds a current state, having a current node, and that allows us to, externally enable iterating through the list. Basically it's just the fact that it holds the current node. And so since we only have one iterator, we can only have one iteration through the list at a time. But internally, I also provide a second iterator for instance, for the insert sorted method, which is, I use it there just to clean up the code a little bit. Okay, so that's how the iterator works. I don't think I need to show the code for that one. It's fairly simple, just the fact that it holds a state of the current node. And yeah, okay. So moving on to the template pattern. For the template pattern in my sprite manager, you can see here I have a derived create node method, and so this is my template method. And in my base manager is where it's called and also defined. So here's my contract. I say anything that derives from base manager must give me a method or a implementation of creating a node. And so in my reserve pool or refill the reserve pool method, I simply call that derived implementation. Okay, and so moving on to the composite pattern, I kind of already showed this, but just to show it again, I create a grid, and passing in that grid to this method, I add a column to it, or in the case of the column, I add game objects to it. Well, alien objects. And so moving on to the null object. For the null object, I have a sprite proxy null. I use it in another instance for the collision, but I figured I wouldn't show that one yet. So for the sprite proxy, I have a additional sprite proxy class. So essentially what this is doing is the update and render method for the sprite proxy is they do absolutely nothing. And so it enables us to provide a sprite proxy, but it has no implementation. So for instance, for our composite objects, they don't have sprite, and as such, they don't need a sprite proxy. So instead, we give them the sprite proxy null. And I just have one instance of a static sprite proxy null that is shared for any composite object. So for each instance of our column or grid, this will be used as its sprite proxy null. And yeah, so the game object will still update the X and Y variable of the base of the sprite proxy because it inherits from that. But when we call render, it will do nothing, which is the key part. Okay, and then for the adapter pattern, this one for the texture especially, it's very simple because the texture really doesn't have a state that it maintains. But essentially, the adapter pattern just is saying that we have a wrapper around the Azul texture, which is an interface we don't want to have the client deal with. And so we wrap around that, and we provide the appropriate tools to interact with it. So for instance, being able to get the actual texture, and then being able to set the texture with a given name and with some filters parameters. And now to actually run the game. Yeah, so you can see I'm able to move right and left, and you just saw after 3 seconds I replaced the crab images with the red and green bird. And so just I'll let this finish out going left to right. And so you can see that it's able to move both directions, and it would keep on bouncing if I let it go. Just to briefly show how I'm doing the changing of the sprite of the images, I have a command that I set in here to, after 3 seconds, it triggers, and all it does is it finds the images, removes them, and then will add to front. And because I am using the, the 1-1, I have no reserved nodes. It just, the sprites, the crab sprite does not recognize that the images has changed. The image content has changed, so it just uses whatever's there. And I have to do it all in one frame, otherwise we would, probably get some issues. But nonetheless, this is what's allowing me to switch to the red and green bird.